Hello everyone. So in this short video we will see how to calculate the norm of a vector in MATLAB. So first we will see how many types of norms are there that we can calculate in the MATLAB. So the first command that we use is norm v comma p, where v is the vector of which we are going to calculate the norm and p is the norm which we are going to calculate. For example, if we are going to calculate the 2 norm, then the value of p will be replaced by 2. And in case if we are going to find the infinity norm, then the value of p is going to be infinity, which is inf in MATLAB. Okay, so before starting we will clear the workspace and we will clear all the workspace as well as the command window. So we will run this section. And then we come to declaring this vector. So I will remove the semicolon so that we can see the vector, and if we evaluate this selection we can see the vector 1. So the vector 1 is a vector which is a row vector and it has 2 elements. So it is a vector which is in 2-dimensional space and it contains real elements. So if we simply write whose vector 1. Okay, so here we can see the size of the vector. It is saying that it is a vector 1 is a variable which is of size 1 cross 2. That means it is a row vector. So with this being done, we will see how to calculate the Euclidean norm of this vector. So what is Euclidean norm? It is the square root of the sum of the squares of each of the element of a vector. So in this case, in the vector 1, the second norm of this vector can be calculated by taking the square root of the sum of the square of both the elements. So in this case 3 is the first element, and if we take a square of it and then we add the square of the second element, which is 5 squared. Okay, so this is 5 squared and this gives us 34, and if we take the square root of this particular answer we will get 5.8310. So by the definition of the Euclidean norm, this is how we find it, and its value is 5.8310. Now if we calculate the norm using the inbuilt function norm vector 1, and this 2 signifies that we are going to take the 2 norm of the vector. So if I execute this, we get the same answer. Norm 2 is 5.8310. It is same as we have calculated above directly using the formula. So this is the formula that we have used. If we evaluate using this formula, which is the mathematical way, we get the same thing. So MATLAB also does the same thing inside in the background. The norm function is implementing the same thing. The other way of finding the 2 norm of a vector is by multiplying the vector with its transpose. So in case of using this particular method where we are multiplying a vector with its transpose, we have to make sure that the dimensional compatibility of vectors is correct. So in this case the vector is a row vector which is 1 cross 2, so it should be multiplied with a column vector that is its transpose, which is vector 1 dash, which is as written here, vector 1 dash. So by doing a vector multiplication or a matrix multiplication of the 2 vectors also, we can find the vector norm or the 2 norm of the vector. So this is also 5.8310. So we see that this is how we find the 2 norm or the Euclidean norm of this vector 1. Now we come to the 1 norm. 1 norm is simply the addition of all the elements of a vector. So if I calculate the 1 norm, it is giving us 8. Let us clear the command window so that it is clearly visible. Now we evaluate the norm 1. So the 1 norm of the vector 1 is 8. So what is this? It is simply addition of all the elements. So in this case vector 1 has 2 elements 3 and 5, and if we add them we get the answer 8. The same is being done in this line also, in this statement also, where we are showing that we can find the norm 1 of a vector just by adding all the elements of the vector. So if we evaluate this selection, we again get an 8, which is 3 plus 5. Now coming to the third norm, which is the infinity norm. The infinity norm gives us the element which has the largest absolute value in a vector. So if we execute this, we are getting an answer of 5. We can see here that in vector 1 we have two elements only, 3 and 5. So if we try to find out the infinity norm of this particular vector 1, we are going to get a 5, which is the largest element, or the element which has the largest absolute value. Since both the elements are positive here, therefore the element value itself is the absolute value. And the same if we go with the negative infinity norm, which is this, we are going to get the smallest value in this particular vector. So it is 3. Okay. So this is how we find the norms of a vector. Now we make certain changes. Let's say we make 3 minus 5, and why we are doing this? To verify what the output of the infinity norm is. Now if we evaluate the selection, we are again getting 5. So this particular demonstration is just validating that the infinity norm, what it returns is the element which has the largest absolute value. It is being returned as the infinity norm of the vector. In this case, we have already seen that it is a row vector. Now in the second set of examples, let us clear the command window. Here we are using two vectors. One is a column vector and other is a row vector. And what is the difference in the elements? There is no difference. Both the vectors have the same elements. So we will see what difference does it make to the norm of a vector if it is a column vector or a row vector but with same elements. So if we execute this vector v1 is 3, 5, and this vector v2, if we evaluate this, we get 3 and 5. Now to check the dimension of the vectors, we will run the command whos, and in this we can see that the vector v1 is a 2 cross 1 vector, that means it's a column vector, and v2 is a 1 cross 2 vector, that means it's a row vector. Now we calculate the norm of these vectors, evaluate selection, we are going to get the same result, 5.8310, 5.8310, norm of vector v1 and norm of vector v2. Now why it is happening is that the norm does not depend on the nature of the vector, whether it is a column vector or it is a row vector. Norm only depends upon the elements of the vector. So whether it is a column vector or whether it is a row vector, the norm of both the vectors will be same as long as all the elements of the vector are same. This is also one of the definition that norm is a measure of the length. So we can think about norm in terms of length also, that it is measuring the length, and that measurement of length can have its own definitions, that what is the length here. So it can have its own definition, and based on that we have different norms like norm 1 norm, 2 norm, or infinity norm. Now the same example is now demonstrated for a vector which is a 3-dimensional vector and it has real elements. So it is a vector in R3. What is being demonstrated here is that although all 4 vectors are different, so you can see that vector 1 is a column vector with elements 2, 1, 3. So if we want to look into these vectors, we can simply check them out right here. So first we will clean the command window and we will evaluate this section. So you can see that vector v3 is a column vector 2, 1, 3, and if I evaluate this is a row vector 2, 1, 3. Now this vector is totally different from both the above vectors. It is a column vector but it has elements in the order 3, 1, 2. Similarly, we have one other row vector which is 2, 3, 1. So we can see that the elements in all 4 vectors are same, but the order of the vector and the nature of the vector, order of the elements in the vector and the nature of the vector are different. So in some cases 2 is coming first, and I mean there is a permutation and combination of the elements of the vector within a vector, but all the elements are the same and the size or the number of elements in each of the vector is same. Only the dimension is changing, like the column vector or the row vector. Now if we find the norm of all these vectors, so the norm for all the 4 vectors will be same. The reason being that the norm is independent of the type of the vector or the dimension of the vector, and it depends only on the number of elements in the vector. So if we calculate the norm, we are going to get the same result for all the 4 vectors. So this is what we can see here. Norm of v4, v3, norm of v3, v4, v5 and v6 is all the same. So this is how we find the norm of the vector in the MATLAB. So that's it for today. Thank you.